Good morning friends, welcome back to our YouTube channel. Today we are starting chapter 11, that is thermal properties of matter on that problem. In the last class we have finished that lesson. Today we are starting the problem. Now in this first one we have to consider here. Now let us consider the triple point of the neon and the carbon dioxide is or are 24.57 Kelvin and 216.55 Kelvin. Express this temperature in the Celsius and the Fahrenheit. Now in this condition, just we have to express the temperature. One is in your Celsius and other one is your Fahrenheit. Now in this case, what they have given, first we have to write. Now let us consider the data. Now 24.57 Kelvin. Let us consider the temperature T1 is equal to 24.57 Kelvin. Next, again one temperature T2 is equal to 216.55 Kelvin. Now here we have to express the temperature in the Celsius and the Fahrenheit. Now let us consider the relation of the Kelvin and the Celsius. Kelvin and Celsius. The relation between the Kelvin and Celsius, we are considering the formula as Tc is equal to Tk minus 273.15. Let us consider the relation of the Kelvin and Celsius. We are considering Tc is equal to Tk minus 273.15. Now in the same way we are considering again one more. One is the relation between the Celsius and Fahrenheit. In this we are considering the formula as 9 by 5 Tc plus 32. 9 by 5 Tc plus 32. Now according to this we have to find the first one is for neon. Now in this, now let us consider here Tf is equal to, first condition Tf is equal to 24.57 Kelvin. Now by using Tf we can calculate the value of Tc. Now according to this Tc is equal to, we are writing 24.57 minus 273.15. The total answer of 24.57 minus 273.15 is equal to, we are getting the answer as 248.58 degrees Celsius. The total answer of Tc is equal to, we are getting minus 248.58 degrees Celsius for the neon. In the same way we have to calculate in the Fahrenheit, that is Tf. Now Tf is equal to, first we are writing the formula. Tf is equal to 9 by 5 into Tc plus 32, or this can be written as Tf is equal to, put the value 9 by 5, the value of Tc, temperature at Celsius is minus 248.58 degrees Celsius plus 32. Now the calculation part is there. Here we have to find the value of the Tf. Therefore Tf is equal to, we are getting the answer as 450.55 degree Fahrenheit. This is for the first. For the neon, the temperature at the Celsius is equal to, we are getting the answer as minus 248.58 degrees Celsius, and for the neon at the Fahrenheit we are getting the answer as 415.55 degree Fahrenheit. In the same way here we have to calculate for the carbon dioxide. Again here also we are considering the same value. Now let us consider for the carbon dioxide. TF is equal to second one 216.55 Kelvin, and here we have to find the value of TC. TC is equal to 216.55 minus 273.15. Here the calculation part for TC we are getting the answer as minus 56.60 degree Celsius. Now again here we have to find for the Fahrenheit. TF is equal to, first write the formula, 9/5 TC plus 32. Now put all the values. 9/5 TC is minus 56.60 plus 32. The calculation part for the TF is equal to 69.88 degree Fahrenheit. The answer for the temperature in the Fahrenheit we are getting how much? 69.88 degree Fahrenheit. First one we have to find for the neon, and second one we are finding for the carbon dioxide. Okay, from the question just we have to express the temperature in the Celsius and the Fahrenheit. Here we are getting Celsius and the Fahrenheit. There also in the carbon dioxide we are getting the answer in Celsius and the Fahrenheit. Now let us consider the second question. The coefficient of the value expansion of the glycerin is 49 into 10⁻⁵ per Kelvin. What is the fractional change in the density for a 30 degrees Celsius rise in the temperature? Here they have given that the coefficient of the volume of the expansion of a glycerin is 49 into 10⁻⁵ per Kelvin, and they have also given that fractional change in the density. Okay, we are considering delta T is equal to 30 degrees Celsius. Here we have to find the density, that is delta rho. Delta rho is equal to question mark. Now according to the formula, let us consider gamma is equal to delta V by V into delta T. Gamma is equal to delta V by V into delta T, or this can be also written as delta V by V is equal to gamma into delta T. Delta V by V is equal to gamma into delta T. Now let us consider the formula for the density. Density is equal to mass by value. Mass by value. Or this can be also written as rho is equal to m by v. Rho is equal to m by v. Or v is equal to rho by m by rho. V is equal to m by rho. Now by using this we can write that the change in the density by the original density is equal to gamma into delta T. The change in the original, or the change in the density by the original density is equal to gamma into delta T. Now using this we know the value of the gamma and the delta T. Therefore delta rho by rho is equal to, the value of the gamma is 49 into 10⁻⁵, and delta T is equal to 30 degrees. Now the calculation part of the delta rho by rho, we are getting the answer as, total answer is equal to 1470 into 10⁻⁵. The answer is 1470 into 10⁻⁵, or this can be also written as the change in the density by its density is equal to 1.47 into 10⁻². 1.47 into 10 raised to minus 2. Therefore, according to the question, here we have to find the fractional change in the density. Okay, the fractional change in the density, we are getting the answer as 1.470 into 10 raised to minus 2 or 1470 into 10 raised to minus 5. Now, next question. An iron sphere has the radius of 10 centimeter at a temperature of 0 degree Celsius. Calculate the change in the value of this sphere. It is heated at 100 degrees Celsius. The coefficient of the linear expansion of the iron is 11 into 10 raised to minus 6 per degree Celsius. Now here we have to find the change in the volume of the sphere. Now let us consider first the radius of 10 centimeter. R is equal to 10 centimeter. Convert this radius into meter. Total answer R is equal to 0.1 meter. Next, they have given that temperature. One is T1 is equal to 0 degree Celsius. And other one, they have given T2 is equal to 100 degrees Celsius. Now here we have to find change in the value. Delta V is equal to question mark. Next, they have given that the coefficient of the linear expansion, that is alpha, is equal to 11 into 10 raised to minus 6 per degree Celsius. The formula for the coefficient, they have given alpha is equal to 11 into 10 raised to minus 6 per degree Celsius. Now gamma is equal to, let us consider 3 into alpha. Therefore 3 into 11 into 10 raised to minus 6 is equal to 33 into 10 raised to minus 6, the value of the gamma. Now next, we know that gamma is equal to delta V by V into delta T. The formula for the gamma is equal to delta V by V into delta T. Or delta V may change in the value. Delta V is equal to, we are considering as gamma into V into delta T. Now the formula is delta V is equal to gamma into V into delta T. Now let us consider, we know that V is equal to volume formula 4 by 3 into pi r cube. We know the value of the radius r is equal to, we are considering as 0.1 meter. Now put all the values, 4 by 3 into 3.142 into r cube, 0.1 raised to cube. Now next, the calculation part for the value V is equal to, we are getting the answer as 4.19 into 10 raised to minus 3 meter cube. 4.19 into 10 raised to minus 3 meter cube. This is for the value. Now next, we have to find for the change in the value. Therefore, delta V is equal to gamma into V into delta T. Now put all the values. Gamma is 33 into 10 raised to minus 6. V means 4.19 into 10 raised to minus 3. And delta T, the value for the delta T we are considering as 100. Delta T is 100. Or to find the value of delta T, we are considering delta T is equal to T2 minus T1. 100 minus 0, that is 100 Kelvin. 100 degrees Celsius. Okay, that only we are considering here. Now the calculation part, 33 into 4.19 into 100 into 10 raised to minus 6 and 10 raised to minus 3. Therefore, the value of delta V is equal to 1.38 into 10 raised to minus 7 meter cube. 10 raised to minus 7 meter cube. Therefore, the value of the delta V is equal to 1.38 into 10 raised to minus 7 meter cube. Now, in the question, the change in the value of the sphere when we are heated at the 100 degrees Celsius, we are getting the answer as delta V is equal to 1.38 into 10 raised to minus 7 meter cube.